Okay, so this is in module 1, and this is just a unit on all things CNC, and then we'll cover this one, and then we may try to jump into, I think module 2 has CNC turning on it, and we'll look at those things.
Are you recording this one today?
Mm-hmm. Yep. Yeah. So CNC machine, CNC stands for computerized numerical controls. Before that, they were just NC, they were numerical controls. The idea is that they perform complex operations faster, more accurately, and consistently. And like we've talked about before, it depends on the situation. Everything has some variables to it, but for the most part, I think that that's a fair statement that your CNC machines produce more complex operations faster and consistently. There's definitely times as a one-off on a manual machine can happen faster, not always. This is the TL1. This is actually the lathe that you guys have been working on. It's just a couple years older than what we have. These machines used to be, so TL stands for tool room, so they were actually meant to be basically manual lathes with a CNC control on it. These, especially the ones that have the red hand wheels on them, we have 2 of them that have that on there. You can actually let those hand wheels turn, you can turn those hand wheels. When we started buying those machines, they did not come with the enclosure that they have on them now. We ordered those enclosures. It's funny because the American models look like this. The models for all other countries had the enclosure around them. So they were the CE compliant. And so when I ordered them, I said, I want the CE compliant doors. And they were like, but you're not in Europe. I was like, I don't care. I said, I need some doors on this thing. And then other people must have been saying those same things too, because they made model changes pretty fast after that. But you can see this pretty much looks like a manual lathe. It's our slant bed lathe. It's the same thing, except for you kind of just look at it in a different position. The tool runs like this, and it actually runs upside down. The spindle spins the same way, but if you were to take the lathe and rotate it this way, it's the exact same thing. So it does have a different look. These are typically your ones that have conveyors. These are made more for multiple pieces. These can definitely do multiple pieces. This is what you're going to set up in like a shop where you're doing multiple parts. This actually has twin spindles on it. So,
Spindles?
What's that?
Did they actually have something other spindles?
This has twin spindles. So you've got your main spindle, and then after the part gets done on the front side, a second spindle will come in and grab it, bring it over here, and then it'll turn the back side of it too. So you've got both sides coming off at the same time. So you can have twin spindles, twin turrets, parts catchers, bar feeders. The idea is that as much money as you have, you can make this as automated as you want it to be. So like literally when we run our wheels, I set the wheels up to run. It pulls the stock out of through the chuck, runs the part, drops it in the basket, pulls the next part out, runs the next one. I set it for how many parts I want. When I come back in the basket from the parts catcher, there'll be however many I tell it to run, just sitting in there. So I'll never even open the door. I just walk up to it, tell it how many times I want it to do. Magic money machine is what I like to think about it as. Our TM mills are the same thing. TM is tool room mill, and these mills are designed to be really a manual mill with just a CNC control on it. And that's really kind of how they started. TMs don't really look like that anymore. They look more like this. This is VF3. This is what we have. And so really so VF, just a little bit of Haas history. Haas wasn't originally a machine company. They made rotaries, so 4-axis and 5-axis rotaries that went on existing CNC machines. They then decided that they would build their own CNC machines, and their very first mill become the VF. So it's VF is very first. And so it's pretty cool. I mean, they got a pretty cool history. 3 is the size. That table size is about 20 by 40. And then they've got a 2 and then a 1. And so they get bigger or smaller. You have the CNC program that's created in the machine control unit if you build the program at the machine, which we do oftentimes. We can offline program as well. Machines located Machine locates axes from programmed commands. You have drive screws, you have guideways, you have servo motors, you have ball screws. There's a lot of pieces that are moving inside of there. One thing about that machine is it doesn't care what it does. It doesn't care if it does tax software or if it does taxes or makes spaghetti noodles or makes CNC parts. It's just motors controlled, has no feelings, has nothing about it. The thing that makes these machines so accurate is they have a ball screw and a ball nut. So if you'll notice that the screw is shaped like it's got a full radius in there, and instead of a nut just having the internal threads on it, it actually has ball bearings that roll through it. That's why when you replace one, it's so expensive. So like on one of our super mini mills, we've had the ball screw replaced on it. This thing is about this long. It's a screw about this big around, 10 grand. And, but it's also the thing that drives the complete x-axis and holds its accuracy. So that's how you build such good accuracy for it. So ball screw and nut, very important. And then you have your linear guides, sometimes called trucks, that these run on there. They have ball bearings on there. That's again what helps it to just keep moving and be so accurate. Lubrication is really, really important on these machines. And our CNC machines, for the most part, they are maybe beyond the TL1 are pretty well self-lubricated. So everything's on a timer, everything's controlled. I mean, we have to do the grease fittings on our TLs. Everything else, like on our STs, there's not a grease fitting one on those machines. In our lathes, we're typically going X and Z, and then in our mills, we're going X, Y, and Z. Whenever we're positioning, bringing the tool into the part, we always move X, Y first, then Z. And then when we come out of the part, we always move Z first, X, Y after that. And then on our lathes, we're going in X and Z primarily. We want to move Z and then down in X. That keeps, and then the reverse of that would be X and then in Z for internal work. And so you always want to start in those safe spots. Servo motors are the things that drive the machines. That again, they're super accurate. That way, when we use like our STs, they can do milling and turning on the same machine, and it uses those servo motors because they're highly controllable. It's different from like a motor on a belt sander. You turn the motor on, the motor has no clue where it's at, it's just spinning. These motors, at any point whenever you stop them, they know exactly where they are in a clocked position. So those things are important. We have our origins for the mill. If you go like this with your left hand, this will be all of your positive directions. Okay, positive Z, positive Y, positive X. And then if you want to see all your negatives, right hand down, negative X, negative Y, negative Z. Okay. On the mill, there is the machine coordinates, and then there are floating coordinates, which we call the work offsets. We're not using work offsets on our lathes because as we set our tools, we're actually creating the work offsets as we go. So on our lathes, we have primarily two axes that we work in, X and Z. X is the diameter, Z is the length. Anything beyond the chuck is then going to be, from the face of the part back towards the chuck will be negative. Anything in front of that would be positive. You can also have polar coordinates. So as far as angle and length, if you want to, there's a lot of different ways to build these out. So you could do a bolt hole pattern in either X and Y Cartesian coordinates, or you could do it length and angle. So you could
screw my roll up after we leave the blade.
What's that?
This is just gonna screw my roll up after we leave the blade.
But it's incremental. It's small bites at a time. So never is anybody going, hey, here's a print of 50 hole patterns and milling 97 different steps and go. You know, so we start with super simple pieces.
Bobo pattern?
What's that?
What kind of a pattern do you?
Bolt hole pattern, yeah, or just a hole pattern. So if you notice, These are all gonna be holes that are drilled. So, I mean, typically it would be for bolts to go through. But I mean, it wouldn't have to be. It could be just like spot drilled marks, or it could even be like, let's say you're gonna make a clock where you just tapped every one of those things and just made a mark there. But you can see it's in the clock position. So you've got 90, you've got 45, you've got 0, and then you keep kind of going around the clock. Every one of these, if you were to go in polar coordinates, you would see 7 as far as the length, and then 90 as the angle. Then still 7 is the length and 45 is the angle, and then 7 is the length and 0 is the angle. But if you were doing it in Cartesian coordinates, this would be x0, y7. And then this would be x7, y0. So just your Cartesian coordinates.
Why two different sets of coordinates, different systems?
Well, I think everything, it's like chocolate and vanilla. I think some people would like to clock things based upon angles and lengths. I would rather do the X and Y coordinate values of it. But if you had, let's just say you worked at a company that made, they always made this bolt hole pattern, but depending on the model, it shifted some. Well, it would be easy to just go, okay, it's not 0, 45, or 90, 45, 0, but it's 80, 35, 10. It's really fast to change that. Where if you had to go Cartesian coordinates, you'll have to figure up all the math for where all those pieces are. So our controls will do either one. They don't really care. I am typically an XY coordinate person, depending on what it is that I'm working on. Okay, again, Cartesian coordinate systems will be really important to us. G-codes are codes themselves. G-codes, they call these preparatory commands, set mode, or motion commands. Okay, so your G1 is your feed move, your G0 is your rapid move, your G2 is a clockwise move, your G3 is a counterclockwise move, your G4 is a dwell. So they kind of go numerically up, and they actually have families. When we get to it, you'll see that they're built in family structures or groupings. And so same thing with M codes. M8 turns a coolant on, M9 turns a coolant off. So they work together in those statements. Bits we won't ever have to worry about. Conversational programming is when you go in and it'll have a template. Let's just say you want to make a 3/8 threaded section that like we've been doing. It'll say what size is your stock? How far back do you want to turn it? What diameter do you want to turn it? What threads do you want to turn on it? What tools are you going to use? You answer the questions and it develops a program for you. So it is very nice. And if your job fits those parameters, that's the machine for you. They're very fast to learn. It's literally just kind of prompting you to the next question. The problem is when you want to put, let's just say you want to do these threads, but now you want to do them tapered for a pipe thread. And if it doesn't give you a tapered option, you don't have an option. There's nothing there for you to do. You don't know what to do. So you can do straight threads, but our tapered threads need to be on a 1.783 angle. But there's no way for it to do that. So you're like, what do I do? Like you're jammed up right there. So when I first started CNC, that's how I ran a machine that was similar to that. And we had problems with that all the time. We were like, you always had to lie to the machine about the thing that you were trying to make. And so then when you had to pass down to somebody else, you were trying to explain to them the thing that you needed to do or that they were doing. But you couldn't say, oh, we're making pipe threads here. You would say, so we're telling it we're making these straight threads, but we're actually turning, what we're doing is we're turning at an angle and we're feeding really fast across to develop the threads. And like everybody ends up with, that's where confusion and scrap parts come from. So yeah, it's all about like having the right application. All right, a safe start position is a spot where it does tool changes or moves that's cleared out of the way. material removal or MMR for material removal rate, then all of those things are what we're taking from the material itself. 3D printing is called additive manufacturing. Machining is called subtractive manufacturing. So here is a kind of a quick sample of a part. The origin is in this lower left-hand corner. The tool moves to all of these programmed dimensions across the radiuses and everything. So the tool moves exactly where you tell it to. It does exactly what you tell it to. And you can simply put, if you wanted to just run something really simple in there, you could take a Sharpie and put a piece of paper on the table, and you could draw your name on there. It doesn't matter. I mean, you could take, if you wanted it to mix a cake, you could put a spoon in the spindle and bolt the bowl on the table. Well, one of the Haas videos has, you know, the little wooden track, the little train tracks, they kind of have a little, they kind of link together. They take one of those train tracks and put it on the table, and then they put the train on top of the spindle, and then they have the same pattern, and then they drive the train with the spindle on there. So it literally, it can just do anything that you want it to do. And
It's feasible with spaghetti though.
it would be, yeah.
They're going up, there went $1,000.
Exactly. Same thing with a robot. I mean, a robot can pour a cup of coffee, but I mean, that's what we would do with it because we do a lot of demonstration stuff. But nobody's buying a $40,000 robot to pour a cup of coffee. Most people aren't buying. Most people aren't buying that to do that. I don't want to say somebody is. You know, somebody is doing that. But
Someone with a lot of money.
yeah, you know, and that's fine if you can do that. That's great. You know, but so yeah, I've used our CNC machines to make. I used it as a giant paper cutter one time. We had we were doing Vacation Bible School, and we had to do little picture frames. And so I took paper, stacked it up really tight, and I took like cardstock, folded them in half, and it was like a frame cut out on one side, and you put it together and you glued it. And so I just laid it down, milled all these out, and then they're done. So it's it could be a giant paper cutter too. So you never know. I mean, you can make it do about whatever you want it to do. So a couple examples of just some programming for the CNC machine. All right, so that's it with that one. That is just the intro to CNC. And these slides don't provide every single answer.
Hey, question one, it doesn't even talk about traversing.
What's the first question?
Well, traverse is designed to go you go.
That question is kind of, I actually got it right, but
I don't understand what the first one is even at all.
Go, it usually goes in rapid mode, but I don't know.
Okay.
That's somewhere else.
So it says blank traverse is designed by the
Go.
code G0.
Okay.
Remember, G code, it's going to be a G0. So the word modal means that something stays the same until it's changed. So if I'm in a G1 mode, then I'll stay G1 feed mode until something changes. If I'm in a tapping cycle, I'll stay in the tapping cycle until something changes. Typically that's changed by a G0, G80, something that ends with a 0 to cancel it out. Circular means that, so in my G code list, it's G2 is clockwise, G3 is counterclockwise. Lineal would be straight line. And then rapid would be move really fast. Typically, wouldn't have to be in a straight line, but typically would be in a straight line. So looking at our G codes, Let's look in your book.
Morning.
I knew that it was down.
Coffee sounded way too good this Okay. You want to get the book out?
Only if you want to know the answers. I mean, if you want to do it on your own and don't want to do it here, that's totally fine to do.
Nah, I'm good on that one. Pretty sure I paid for this book. I'm pretty sure I didn't. I don't know. I don't know if I paid for it or rented it or not. Here we go. Yeah, I bought it.
All right. So if you look on page 589,
What page?
589,
That was one of the other videos back.
G0.
G0 really rapid.
Yep.
And that's how I remember it. 'Cause I actually got that one right.
Yeah.
I like it. Some of them are only for the mill.
Yeah, some of them are definitely specific to a particular machine, but most of them, they flow back and forth. Okay, so, blank traverse. So traverse would be motion, okay? So to traverse across something means that if you were to traverse from California to Florida, you would get in your car and go, okay? And so if you would move that way, so modal traverse doesn't necessarily fit, does it? So staying until it's changed, motion doesn't quite fit. Circular motion isn't controlled by G0, is it? What's it controlled by? No.
Oh, wait, no, that's spindle.
You're close though. That is spindle. That's right. So what did I just say for?
Clockwise and counterclockwise.
Exactly. Clockwise and counterclockwise. Circular motion is controlled by G2 and G3. So that won't work. Lineal traverse is controlled by G0. Okay, maybe. I mean, that's straightforward motion, right? That's going across.
One is linear.
Rapid.
Yeah. Interpolation also just means movement. So lots of times people will talk, when they talk about G2s and G3s, they'll be like, that's circular interpolation. I'm like, well, everything is interpolation, because interpolation means that it's taking the information given to the motors and to the servos and to the encoders, and it's interpolating that into some type of movement, okay? So everything is interpolation, but it seems like people have a tendency to say G1 is feed and G2 and G3 is circular interpolation. I'm like, well, those are true statements, but G1 is also lineal interpolation. You could also say G2 and G3 is just circular feed. So those two things, they flip back and forth. All right, so rapid, what's rapid? What's rapid traverse is designated by the G0. Is rapid traverse? It's not?
Yeah, the rapid, the feed, it's, I think G0 is the feed, the rapid feed.
It is just the rapid. So a feed typically is when we're going somewhere designated by a feed rate. Right? Inches per minute, feed per revolution, yeah. So, I mean, it is rapidly feeding to that spot. Yeah, it's rapid motion to that spot.
So it'd be like G0 and then like a position.
Yeah, G0 in a position, no need for a feed rate.
Right.
Yeah, but there's no feed rate attached to it. So it is feeding that way, just because the screw's spinning and the motor's moving. But it wouldn't be feeding like I want it to go at this certain pace. It's going machine as fast as you can, get to the front of the line, you know, that's what it's saying. So yeah, it is a feed, but it's not,
Makes more sense there.
what's that?
Linear just makes more sense there.
Linear, but isn't the word rapid in the designation for G0?
Yeah.
Right. I think that's what it is.
It's,
Yeah.
it is positioning.
Yeah, I'm pretty sure it is.
But I'm just.
Positioning
Linear
at rapid
means-
feed.
Okay. Question 2. Blank coordinates require the position to be identified by both the angle and the distance, like vectors and math. Yeah. And so absolute means from a designated home position. So if this is my 0 point, I want to move up and I want to move over, or I want to move angularly, everything comes from this 0. If I want to move incrementally, I move from here, this now becomes my 0, to move here, this now becomes my 0, this now becomes my 0. So
You can set up multiple vices and run different.
no, so that would be, so here's how I would use the directions, or here's how I would give my example. I don't know, it's a really good example, but if you're gonna map something, so you're gonna Google Map to Arrowhead from your house. Your house is 0, Arrowhead's the destination, and you're just gonna go to there. Everything. That's your origin point. You're going to Arrowhead. If you're going to Arrowhead via Casey's General Stores, then you're gonna go from your home, your origin, to the Casey's out here, and then you're gonna Google Map it from Casey's here to the next Casey's that's closest to the Arrowhead. So that now becomes 0. Now my next Casey's becomes my next point. Get to the next Casey's, that now became my 0 point. From this place to the next Casey's, that gets to Arrowhead. Like you're jumping from point, you're leapfrogging to place to place to place. That's incremental. Every one of those places where you stop becomes the new 0. Now, if you're doing multiple vices on a job, so you got a 20 by 40 table, whatever you have, those are different work offsets. G54, 55, 56, 57, 58, 59, whatever you want it to be. So multiple work offsets is what that's talking about. So you have absolute, that's that. Lineal, which is just moving across there. Incremental, which is what we just talked about. And then polar, which requires a length and an angle. So what do you think? What?
I already know.
Yeah. What do you think? Polar. Right. Requires a length and an angle. Yeah.
I'm gonna get your laptop out and do this quickly.
You should totally be doing these answers, like we are literally answering the questions as we go. A CNC program is created and stored in the machine control unit. Think hard drive, okay? Think of it, that's where it stores everything. Rectangular coordinate system.
No.
Origin control system. Nope. Modal control unit. There are 3 fictitious answers in this one. There's only one right answer in this one.
They call it a pennant in some of them. In some of the videos, they call that thing.
Yeah, oftentimes the pendant is the thing that comes off of here, but you could probably call it, I don't know that I would call it that. But yeah, yeah, I don't know, I'm not sure. Okay. Machine control unit. Okay, question 4. The blank positioning system defines or specifies a distance from the current position to the next position.
They told us that one.
Did. What is it?
Incremental.
Hunter, what is it?
Incremental.
Incremental. 5 extra non-credit bonus points for you. The place a traveler begins from is called the point of origin. Sure it's not foundation? Okay. CNC mills with an automatic tool changer are called. CNC mills with an ATC, automatic tool changer, are called.
Turning centers?
Turning center is a lathe,
Okay.
because it turns.
Okay.
the part turns.
You're saying that's not right?
I'm saying turning centers is not right.
Oh, okay, that's, yeah, I got.
I don't know, positioning mill doesn't sound right either.
Have you ever heard us use the word positioning mill?
No, that's why I'm saying that doesn't sound right.
You said?
Machining centers. Okay.
I got that one right.
Yeah, so the idea is that you move beyond like a vertical Bridgeport mill, where, because a vertical Bridgeport mill is still a machining center. But it's not something, with the idea of machining center means that it's something enclosed, it's something it's something I can drop the part in, clamp it down somehow, and then walk away from it, and then there's a finished one when I get done. The mill does machining center operations. It's just, you've got to be there for every one of those operations. Programming code that the machine can understand is called. So we've already talked about modal. Modal means it stays that way until it's changed. Traverse is moving a direction across, right? California to New York. Word address. Okay. G0 is a word. It's only a word to a machine. It's not a word to us. Right? So, because G code is a machine language. And then encoded. Encoded would be, it means that we see it in one way, but it means something different. But these are codes, but they're not encoded.
Yeah, we can understand them.
We can understand them.
Encoded is like, you can't really.
Right. Encoded would be similar to encrypted.
So that'd be like something, walk up to the computer, be like 0001.
Right, well, and that'd just be bits.
Firewalls.
But you can understand bits.
Yeah, but that sucks.
But you can. I mean, whether it sucks or not doesn't mean that you can't do it. But you can see 0001 means turn the thing on or turn the thing off. So those aren't even encoded. Like a BitLocker is encoded. So a BitLocker, you would put in your phone number as the password, and it would translate it to a different set of numbers, letters, or code. But what you see or what you type is not the same thing that comes out the other end. That's encoded. So something different than what it's doing. So, and there was a slide that we really just zipped past called word address. And the way word addresses work is it's the machine's sentences. Especially our new systems and our programming. If I type, this will probably erase well, but green probably won't write well because it seems like the markers dry out every day. So programming from an older style, let's just say 80s and 90s.
Floppy disk.
In the 1980s and not the 1880s.
Floppy disk.
Floppy disks, absolutely. So here's how they would read a code.
My grandpa said they used to use floppy disks, and I didn't believe them. Unlike on the machines, I didn't know that's what they used to.
When I started, we used tape readers.
That's bad.
Y'all don't even know what a tape reader is. I mean, you can imagine though. So here's what we had is there was a long piece of tape, and you punched holes in it.
Like a card reader. in your
Card reader,
machine,
yeah, like a Scantron, kind of thing, almost like a Scantron. But you punched holes in it, and it read that code. And it's funny because our CNC code today actually still retains some of this code. So M30, program rewind, also ends your program. So we use it as program end. It's not really program end. M2 is program end. M30 is program rewind. And what it means is that when it gets to the end of the program, it rewinds the tape.
Oh.
Yeah. So like on our Akuma lathes and mills that we ran at the shop I came from, you always ended the program on M2. But if you were to run a tape reader, you would have had to run M3. And in the time that I was there, I don't know that we ever ran a tape, but our machines had tape readers on them, and we had tapes. We even had, you said floppy disks, and you're thinking like 3.5 floppy disks that are hard?
No, I'm not about them flimsy.
5 1/4s that are flimsy. Have you ever seen an 11 and a half?
Uh-uh.
We had an 11 and a half. It looks like a record still in the sleeve,
Yeah.
but it was floppy, and you slid it into the machine. And we even had a machine that had like reel to reel on it. It's like I don't know if you think of a cassette tape on steroids
Without a case around it.
without case around it. So you had a reel that had the spool, the tape on it, and then you fed it into a empty spool, and then it wound into it. I wish I would have took pictures of these millions of years ago. Yeah, I mean, we had stone tablets that we were doing this on. But I mean, it was like, even for us, when we got these machines, we were like, what is that? And one of the machines that we came with a giant floppy disk, and I was like, I'm not even sure what to do with this.
I feel like if I would have had a choice to take that home with me, I definitely would have.
Just walked
So
off.
probably someone did. So one of the owners of the shop, so when I originally started the shop, we had 4 owners. Pretty quickly, one owner retired pretty quickly. The other owner retired pretty quickly after that. We had 2 owners. One was insanely smart, really good with computers and stuff. He probably took one home. That would have been something that he would have found really interesting. He is very smart. He actually owns, what's the tire place across from Menards? That's not Meineke, is it? That's
Midas, isn't it?
Midas.
Yeah.
He actually owns Midas now. So, anyways, so older code would read statement by statement. Tool 6. What do you want to do with tool 6? I want to change the tool. Now we read sentences. Change to tool 6. So it doesn't matter the order of the code. So let's just say M6, T6 does the same thing. Older machines, it mattered the code that you put in.
Now we're back in math class. Just yesterday, we were doing the whole thing.
Order of operation.
Yep.
Yeah.
Parentheses.
So in new code, there is no order of operation as far as a sentence goes, okay? So obviously there is some order of operation. You can't move before you do some other things, so there are some order operations, but not really. All right, so this would be word address. A blank is a hybrid electric motor with half motor, half position sensor. Okay.
Good guess, I did.
So it is, okay, it's not block and it's not modal, because I've said modal 15 times and that is not what I mean. So yeah, there's a encoder, but an encoder is not a motor. The encoder just reads the position of what it is. So servo motor knows exactly where that shaft is positioned at all the time. Blank codes are used to turn on and off miscellaneous or auxiliary functions. It starts with an M, right? Like it practically tells you. It's an M code. So M codes turn coolant on, coolant off, spindle on, spindle off. Even though spindle is motion, it's not really lineal motion. Most modern CNC machines employ a high-tech motorized version of ways called, is it called linear interpolation?
Not modal, no. Nothing's modal.
It's definitely not modal, yeah. Okay, so the first one, last one's out. Origin guides.
I like linear something or other.
It's linear guides. So when we were looking at the slide and I said the word trucks, that's the slide that we were looking at that has linear guides. So think about it like train track, but instead of the wheel being on it, like a much more precision kind of clamp that goes on it, and it guides along that lineal rail. Okay, so it's locked on there. That's how we build that precision into it. Okay. All right.
40 points down, let's keep going.
You want to do another one?
Not really,
I
I'm gonna
can.
run parts and watch Hawes videos the rest of the day.
you basically, you gotta get them done either way. I don't care.
I know, but I have no internet in my house anymore.
Okay, you gotta do this with internet too.
I know, I'm just saying.
So, what do y'all wanna do? Do you wanna go out to the shop, or you wanna keep going here? You wanna do another one?
Well, I'm always ready to do another one, but that's.
Yeah, I don't care.
Hunter, what you wanna do? That's not an answer. Okay.
So he doesn't wanna go out to the shop.
Shop would wake you up, sitting here listening to Justin talk to him, put you to sleep.
I feel like I'll get caught up in it because of how tired I am. I feel like I'm gonna fall asleep on it.
It's gonna get stuck into the machine.
Yeah.
Okay,
So I'm gonna stay in here.
okay.
Some coffee.
Got some tweaking.
For this.
I don't know if there's much.
Either way,
coffee.
okay, all right. Let's do one more, and let's try and get ourselves caught up. You guys are not good at answering. Like, two of you were good about answering questions. The rest of you are like, you just talked around it.
Hey, man, that is true, I talk around everything, so thank gosh. You've had me for what? At least
You doing unit
10
two?
weeks now. I'll tell you what, my attendance in college is a lot better than my attendance in high school.
Oh, yes.
I've missed like 2.
Well, in college, if you miss, you just hurt yourself.
Yeah.
That's, yeah.
In high school, I'm like, yeah, whatever. Just some social studies work, I don't care.
Yeah.
Okay, so which one are you?
Yeah,
I'm in section 8, unit 2. It is in module 2, I believe.
Yeah,
Yep.
it is.
I think there's 2 of them in module 2. There's a section 8, unit 2
This
slideshow.
only has 8 questions.
47 slides though. That's not true.
See how many slides?
34 slides.
Hey, it's not too bad then.
Yeah. Okay, section 8, unit 2, introduction to CNC turning. We've already been doing this. These things should be very, they shouldn't be, shocker to you. Okay, do that. Alright, so the CNC lathe, is similar to a manual lathe. It moves in Z lineally and then radially in X. Okay, so you've got 2 axes. On the most basic lathe, you have X and Z axes. Okay, and so like yesterday we talked about our lathes out here have C and Y, and so but our basic structure 2-axis
The
lathe.
ones we use, they have Z, X, and A.
Well, but A is not really an axis. A is
Axis, just the.
What is A? 'Cause
so A is just a rotation of the turret. So if the base model of this machine does not have that turret, and so to home it out, you would just hit power up restart, and the 2 axes would go home. Since we had the turret put on it, since it does have programmed motion, they give it a designation of an axis, but it's not really a axis. Where
You can't really control it, it just switches to a different.
yeah, you're not doing a machining operation with it. We're like on our mills, you have Z, you have Y, you have X. Rotary about the X axis is the A axis.
Is there a way to do like an A-axis, like let's say you wanted to put, actually that doesn't make any sense at all, actually. Big brain. Like on the lathe, on the manual lathe, how we turn our, I don't know, it's not a turret, but where we put our tool holder, we turn it to a little bit anchor to add a chamfer or whatever on the outside. Can you do that to a turret? Can you turn it to like a 1/2 degree?
So
Or does it
on
not
these,
work?
no. But I don't know why you would want to, because you would just program that angle.
Yeah, you can just program it in there.
But yeah, so not really, no. Now they even have manual lathes that have turrets on them that indexes around in like 8 stations. Or they have them sometimes where the tailstock has a turret that you, like if you did, like especially for like bullet production, like old war machines, that's how they are. They've got a turret that's essentially kind of the tailstock. You drive a spot drill in, index it, a drill in, index it, bring it in a reamer, index it, and then part off, and then you just keep popping them off like that. And so it's a kind of a it's a production machine, but it's manually operated. So, so that idea of a turret that rotates automatically isn't really a new thing. And so, yeah, really, they just kind of index to positions. They're not really programmable, even though they are considered to be an A-axis. But that's a pretty complicated designation because it makes you think it does something that it doesn't. Okay, here's not the best description of what this is, but the origin point is generally located at the center point of the face of the part. Okay, so front of the part, Z0, center of the part, X0. So middle of that baby is,
Like, say we had our 2-inch stock sticking out the end.
right, yeah, let's just say this sticking out the chuck, middle of this X0, front of this Z0. Almost always. So there is no always and never, but there's hardly any always and never. But for the most part, you know, these are pretty standard things. Okay, here is a slant bed lathe and slant bed turning center, and again, it's the same thing. It's just rotated, and it doesn't really matter how you rotate it. A friend of mine who works on machines once told me, he's like, it doesn't matter the position or orientation of this thing at all, as long as it's not twisted. He's like, you can literally hang them on the wall as long as they're straight. He's like, when they twist, then they don't cut straight anymore. That's where you develop problems. He's like, but it doesn't matter if it's upside down, on the wall, or on the floor, as long as it's straight, it'll cut right. So, like, when you look at it, because lots of times when people go up to the slant beds, they're like, how am I going to do this? Because the tool, I can't even see it to change the insert on it because of the position of where it's at. That is true. And if you were to run it with the doors open, it shoots chips in totally different directions. So you would just get like.
So what's the meaning of this design if it has all those problems?
It only has those problems if the door is open or the operator is right there. This machine is meant to be enclosed. Push the button, walk away, do another function, come back when it's done. That's what it's meant for. And so if you've ever seen like this ST run, doesn't matter if I'm there or not, I said run 5 parts, hit cycle start, I walk away. When I come back, there are 5 parts sitting in the bucket. And however many times I tell it to do it, that's what it's going to do. So I can say, I want to run, like let's just say I want to run parts overnight. Let's just say I had a side job, making parts for somebody.
He definitely does.
I definitely do not. Definitely not a good moral thing to do, yeah. I mean, now if I were to have worked out a deal with the school where I paid them for usage of their machine, that would be okay, but
You want to buy your own anyway?
yeah, I do want to buy my own, but I would not, the only way I would use these is if I had total approval of the school to do that. We don't want to do that because we don't want to become what they would call a profit center. If we become a profit center for somebody like Gardner Denver, then I will demand a certain amount of parts from you every day, and rather than instruction, I will be wanting volume from you. So that's not what we want. Like, I don't want to go, hey, I don't care what you learn, I need 50 parts from you today. Then you just became an employee.
A little manipulative.
It's super manipulative. And then you're like, so I'm paying to come here to do this? You know, you don't want to do that. And so,
Paying to come here and do it.
right, but you shouldn't be paying to come here to do this to make me 50 parts so I can sell them to a customer.
Hey, that's what my act shop is all about, man. We are building trailers all
Yeah.
day.
We do not do that. There are a lot of problems that you can get into. And I've been asked by companies for years, hey, if you make parts for us, we'll pay you for them. I'm like, I understand that, but what happens at Christmas time when we're not here? There's an entire month that we're not going to be here. And so what are you going to do with no parts for a month? What about summertime when we go 2 to 3 months with no parts? Are you okay with that? And they're like, no. I'm like, so we're not starting it. You know, we're just not doing it.
Speaking of money, did you find out about the grant,
With the
the Haas grant?
paperwork's in motion. Yep.
It's always in motion.
It is, it's slow motion. There's a big wheel with lots of spokes.
What, the last week of the first 8 weeks?
What's that?
You got all those checks, what, the last day of the 8 weeks almost?
Well, you got them after 4 weeks, because I won't give out checks to people who can still get their money back. So you could come to class and you could drop after you get your check. So I mean, I'm not smart, but I'm not stupid.
Right.
And
Give me a fat ass check, I ain't gonna be here for a couple days.
exactly. So what happens is people will enroll, and just think if I gave you the check on day one, and
Back to class.
I would just enroll into programs every single semester.
Everything.
I mean, why wouldn't you? You know, if you know you're gonna get $1,000 every time, yeah, sign me up for micro blah, blah, blah.
Why don't they make you give it back if you?
So they would try,
Yeah.
but I mean, how would they? I mean, here's what they would do. They would be like, you can never take classes in the state of Missouri again. Who cares?
They can't like tack it out of your check or anything.
I mean, how would they do it? I mean,
Like, not cool, man. Not,
that's the problem.
Basically all they can do.
Not cool.
Not
Yeah.
cool.
So like you would owe a bill, and you would not be able to go to another state school in Missouri. But that would be it.
Really? That's kind of a big deal to me. What if I want to go to school?
So let's just say you want to go to MU. Let's just say 5 years from now you decide you want to be a doctor and you go to MU, and you're like, finally got my life together. I was kind of a screw up back then. I wasn't thinking. You go to enroll in MU, and they're like, well, so you actually owe $1,000. And you're like, oh my gosh, that mistake I made 5 years ago is caught back up with
They
me.
like put you on a list or something?
Well, that's the same thing with me, I have $14,000 worth of loans out in Lynn
At State Tech, yeah.
Or State Tech now,
Yeah.
yeah. And come here, they're like, you got your grant, that's it, sorry.
Right, because those things, they don't go away.
Yep.
Okay, so,
Hey, man, isn't there like forgiveness coming or whatever?
Oh,
yeah, my wife's entire master's program is totally being paid for.
Man,
Is it really?
Yeah,
it's gotta be
you
paid
can
for,
apply
but then we're gonna have to pay it all back here in a couple months.
I wouldn't be surprised at all.
Yeah, when tax time comes, you can go, yep, yeah, no.
So she gets her classes at half price. So if she comes to school here, she goes for free. If she goes to CMU, which she does, she goes for like basically half price. And then they're essentially, I think, is what they're doing is forgiving the rest of her debt. But like, what's crazy is like, we never even asked for it. They're just like, hey, sign this paper. But during COVID, we were doing the same thing. There was a thing on Canvas, and this is how the students are. Thank you. Yes, sir. I think, what are, oh, no, that's spindle holder RPM, at 20,000. That tool can go 20,000. Yeah, don't spend that 20,000. But,
I misread it, I thought it said 2,000.
yeah, you can go 20,000 with that tool. But yeah, you don't want to do that.
Not in this shop, you're not.
Well, one, we don't have a spindle that goes 20,000, but, so.
Why would you need to spend?
So when COVID hit, we had this thing that popped up on your Canvas literally every day. And it said, click here for, I can't remember what it was called. It had like a girl's name on it or something. And it said what it was, but I can't recall what it was. It was $600. You got $600. You push one button, you get $600. And I had students who wouldn't do it. And I would be like, okay, everybody log into Canvas. Go push this button. And they're like, I'll do it later. I'm like, go get the computer. Go log in. Go push this button. And they would do what happens to me every time. They would go get the computer. They would open it up. They would log in and not push the button. And then they would come to me at the end of the semester and be like, hey man, is there any way I can get some extra money from the school? And I'm like, did you get the $600? They're like, I actually never pushed the button. I was like, what did you think it was going to do? Self-destruct? It's not even your computer. Who cares if it self-destructs? I like, what is wrong with you? But, I mean, two different times there was like money that was available during COVID. One was 600 and one was like 1,200, I think. And I had a lot of students who were like, yeah, I actually just never did that. I'm like, I wish I could have done that. I can't do those things.
Papa was probably paying for it.
Even if their parents are paying for it, that money would come to them. And like,
Yeah,
I don't even get it, man.
that's what's
It's
new
just
to
like me,
me.
I have a guardian right now, but
Like, you
When I
can
get
put
that
the
check,
address of
you're
where
not
you
gonna know
want the
that.
money to go.
I am not telling him I get this check.
Nah.
That's why you have a.
Okay, we'll keep going here. We got sidetracked. All right, so slant bed lathe, and then here we have, for a live tool machine, they have a drive shaft, and, I'll go grab one and kind of show you how it works.
Tell us what a live tool machine is.
Okay, I'm gonna tell you.
Some big old machines over there. Any,
No, it's right there on our
There's
legs.
one
It'll,
though.
it'll do like the exact same thing as a drill, but it's gonna also like engrave.
you can, live tooling is you can switch.
Yeah,
all kinds
it's
of
gonna
crap.
spin as the spindle's spinning.
So in my live tool machine, I can put this tool in the turret. It will hold an end mill, drill, tap, whatever it is I want to do. It will be driven. So my tool, remember on a lathe, the tool is basically stationary. The part is what's spinning. Now I can have the part spinning and the tool spinning. So I could run a mill. So I could take my round part that goes in that lathe and it can come out square. So I could actually mill a square, whatever position that I want it to do in there. So essentially, and I've said this before,
Like on the wheels you're doing.
yeah, on the wheels that we do engraving around the outside, milling on the inside, and some drilling on the inside. Essentially, what I could do, if I had the right size parts, actually I had a friend that had a shop that he made little square parts for Swisher mowers, and he ran them on a lathe. He bought square stock, he had a square collet, he ran them in the machine, and he drilled and tapped a hole in the end of it, drilled and tapped them, parted them off, and just put them in the parts catcher, and he'd set it up. His mom would run them, and he's the same.
Hit the go button like you told me to that day?
He didn't even have to do that. It was set up on a bar feeder and a parts catcher, and so his mom would come in she did his books for him in the shop, and every 3 hours she would come and dump the parts, and they had a vibratory so that deburred them. And then she would just take them out. And she was like 65, and she'd just dump them out and put them in the thing, and it just nonstop made parts,
You have a couple $100,000, you need to buy a season series.
How much?
Couple $100,000.
Yeah. I mean, we pay about 100 for one of those, about 100,000.
I don't think you can really just take one of these machines and just set it down inside your house.
Right.
There's a lot of stuff you gotta do.
There are some things, but boy, you'd be surprised. So does anybody ever go to like the Lamont area? You ever go that way? Lamont?
Into Lamont, yeah.
So as you're going to Lamont, is that right? Is that how I want to say it? Yeah, so right around that area, there's a gas station there. I think it was called Roadway at one time. It starts with a Z something now. Anyways, they have barbecue and gas and all the standard Missouri things. There's a building that sits right next to it that had a CNC mill in it, and this guy bought this restaurant, gas station, convenience store thing, and when he bought the property, it had the CNC mill in it, and he had no clue how to do anything, but he knew somebody who said, oh, that's a CNC mill, if you can make me this part, I'll buy them from you. This is just literally just sitting in his little like storage building. And so as a side business, he ran these little like computer circuit board parts for this guy for like years. And so I ran into the guy one time. He's like, I have one of those. He's like, what do you call those? And I was like, you have one? And he's like, yeah. I was like, you don't know what it's called? He's like, I don't know anything about it. He's like, I just put the thing in, put it out. He's like, I Googled how to make the thing. And he's like, I just make this one part over and over and over again. I was like, okay, that's cool. And I was like, how much you sell these things for? He's like, I don't know, like $5 a piece. And I was like, okay. I was like, how many you made? He's like, I don't know, like 10,000 or something like that, And I'm like, oh my gosh, that's great. He's like,
How much electricity is he using?
well, I mean, he was making money.
What's his overhead? Is what I wanna know.
Yeah, he was making money off of it,
For sure, if you're selling about $5 a piece.
I mean, $5 a piece, and if it takes a minute to make one. I mean, $5 a minute is pretty good, you know. I mean, if you're making $1 a minute, you're making $60 an hour, you know. So he was doing pretty well, but yeah, he knew nothing about it, just had it set up. So power-wise, yeah, you got to have some power. There's some power constraints that you got to have. You got to have air. You know, you don't. I mean, on that one, I don't think he probably needed cool, and he was just drilling circuit board stuff. You know, probably just blew some air on it. It was phenolic, is what it was. But, so yeah, I mean, I've seen these things set up weird places, and you know, I mean, if you can do it, you can do it. I mean, in India and Taiwan, don't think for a minute these things aren't sitting someplace in the dirt.
Definitely are.
And they're just running the snot out of these things, man. I mean, they are. All right, so here's an adjustable head. This will be a head that can swivel to do angled holes or something on the mill, or on the lathe. We have 90-degree heads and we have straight heads. We do not have rotated angular heads. Here's a robot tending center. So the robot moves, and then the robot is controlling these 3 pieces of equipment. It's delivering a part at the end, okay? This is a robot that doesn't know if you're in the area, okay? So if you come into this area, it will kill you and not know about it. It's very different from the robots that we have today.
If it makes impact with something, it won't crash or anything.
Yeah, but this is way stronger than you are. It will crash. It will crash, but these things, so like our small robot that sits in the cage, all of our yellow robots are what I consider to be our mean robots. They've got to be caged because they don't know that you're around, and they move at about 30 miles an hour. So when that arm spins around at 30 miles an hour, whatever's on the end of it just becomes a projectile, and like it just doesn't know you're there. Now our URs that we're setting up, they are aware. They are our polite robots. They are going to stop when they come in contact with you, or
We have a lot of sensors and lasers and all that crap to keep them safe.
well, any of them can have that. But these robots themselves, when they come in contact with you, they're pressure sensitive, and so they have feelings, and so they'll stop. So the yellow robots do not have feelings. UR robots do have feelings.
You ever seen that robot that like is leaking hydraulic oil or something?
Yes, that is so cool.
Yeah, I thought that was super cool.
Yeah.
I don't know if it's still running today.
I don't know if it is either. So it's.
It clicked, because we watched it. We kept going falling and falling.
Oh, I know, man. It's an art display is really what it is. But it's this robot that's leaking, and it's trying to clean itself up as it's going. And
It needs the fluid to keep going, so
Yes.
it has to keep bringing it in.
yeah, it's awesome. It's kind of
How long did it run until it?
I think a couple of years.
Oh, yeah, I did.
yes, but it's almost sad because
Yeah.
you know what I
I
mean.
want to feel for it,
I
but
know,
it's
it's-
programmed, so it's like,
Yeah.
how are you feeling for it?
Yeah, I know. I mean, it's one of those things that really kind of gets to you because you're like, bad for the robot. It's like, why do I feel
It's like
bad?
fighting for its life, and people are walking around looking at it. That's cool. That's cool.
No, it's super sad.
Every time we went downtown St. Louis or something.
Yeah.
Yeah.
Somebody would pick that up.
I can't remember where it's at.
Look it up on YouTube.
Oh gosh, don't look it up in here, it's sad.
Look up there, it's sad.
Yeah, it is sad. All right, so here is a mill turn, mill and lathe that's all.
We have one.
Nope, so we have multi-axis, we have live tools, we have, we have everything kind of except for this. This doesn't really fit us very well.
Going out of date, or is it still like a super used thing?
Or is it new?
You see these, it's all specialized, right? So if you need something that does this, then that makes sense for you. But it's probably not the standard out there. Then here's what we talked about before. We use twin spindles. So you've got a part that you make. So this is the part I'm making, and I want it to look like this when it's done. My first operation is over here. My second spindle comes in, grabs it, comes over here. I've got another turret that comes over here and does the backside machining of it. So I can get a complete part off every single time.
Two turrets also.
So you could have 2 turrets. Sometimes just 1 turret, but you just run some of the tools backwards so that they face, one faces this way and one faces this way.
all
It's
sorts of.
best if you have twin turrets, because then you can do twin turrets and twin spindles at the same time. You can actually be doing two different parts at the same time if you wanted to. Program gets a little more complicated in doing that.
You gotta figure out which axis you're on.
You start Windows, you're starting to talk about 9 and 12 axis machines. So
Definitely think 5-axis is way more like up to date or like way cooler than that spindle and mill, dual.
So it just depends on what you need. I mean, if you need a round part that has lots of stuff, then the 5-axis machine isn't quite as good for your application. But it's all about application. So I think everything has its right, its right work. So here's similar to what our turrets look like. So you've got live tools. So these are your mill cutting tools in there. Here are your lathe tools, and here are your stationary tools, and then your rotary tools. Here's an example of twin turrets, twin spindles.
I thought you were about to say twin turbo.
No.
These things got turbos.
Nope. I have turbo.
Called 100%.
Yeah, 200%. Here is an example of what's called gang tooling. All of these tools stay stationary in a row. They just keep moving around to different positions. It's still really very similar to what our turrets are. It's a different orientation.
Got like more axis this way instead of it just turning.
Yep. And so a lot of people actually have on the TLs, they don't buy the turrets like we have, and they build something like this. We actually have thought about at one time putting these on ours to hold stationary tools, because you could actually hold more tools that way. Our biggest problem is trying to get it to hold the right amount of tools. Here is just a really small gang tool turning center. So this is automated, and then you can see all the tools kind of in the row, just a machining center that has it in there. Here's the TL1, which you've seen before. It operates off of the tool post method. And then here you have a collet system. Swiss turn machines are even more different. So here's how a Swiss turn machine runs. It runs a lot like a gang tool lathe, a lot like a regular CNC lathe. It's kind of like it's got everything. And to make matters even worse, you've got your part that sticks out like this, right? So you bring your tool in. Generally, you would bring your tool in and cut it across like this, right? So now on a Swiss turn, you can bring your tool here and you can feed the material out. So lots of times you'll see on these kinds of machines, you'll bring the tool right up to the chuck and it'll go, and we'll keep
I don't know if
feeding
you heard
it out.
mine yesterday.
What's that?
I don't know if you heard my lathe yesterday.
Were you Swiss turning on it?
No, but I touched off everything, but forgot to do my face zero on one. And once the spot drill went to touch, it just shoved my part all the way through the fucking spindle.
Yeah. That's not good. Don't do that. Yeah.
I figured that out quickly.
So what's cool about this is you can do really small diameter parts, and it doesn't want to wobble away, because when it's doing its turning, it's all in a rigid state. So that's really the benefit in that. Swiss turn machines, they move so fast that they are built with fire extinguishers inside of them, because everything's moving so fast. And they use more of a cutting oil rather than a coolant. And they have a fire suppression system built into them. Anytime you look in there and you see a fire system, you're like,
Yeah, because I feel like if you mess up and just decide you accidentally not zero out a face on that and it's moving that fast, I feel like if
oh yeah.
you smack into something pretty good
What's
there.
that?
They're a lot faster RPM.
Oh, yeah, so they're oftentimes smaller parts.
Yeah.
So, yeah, on those, 20, 30,000 RPM is not uncommon. So here you've got your spindle, your tool, your turning tools that come down, maybe some rotating tools here. You've got another turret that's coming in here. Oftentimes you're doing 2 or 3 operations at the same time. So it's turning it, it's milling it, it's slotting it, it's tapping it all at the same time. But so when they do Swiss turn parts or screw machine parts, they don't quote them by the minute or hour, they quote them by the second.
Golly.
That's how fast they run these parts. I've seen There was a place in Versailles that had some screw machine parts. The parts came off of that machine so fast, it sounded like hail. I mean, they were just, you could hear it. So they were vertical. The whole thing laid on its side and it went up. It was like 3 stories up. And it would be just popping off parts so fast that they'd be hitting and it'd be, bah! And it made it sound like hail hitting the thing. I was like, what is going on? He's like, oh. I mean, they were spitting off parts about like this every 3 seconds. And I was like, I can't even imagine that. He's like, yeah, he's like, you don't set this up to run 20 parts. You set this up to run like 250,000 parts. And I was like, how long does that take? He's like, a day. And I was like, I am not in that zone, man. I was like, that's amazing.
You said 20,000 RPM?
So on my advice.
Imagine something flying at your head that fast. Yeah, for
I was
sure.
wondering if I could like get close to the end and like.
BMG going up against,
I wanted to use some of the surface grinding, but when
Today
it's
it's just-
bolted together.
That's fine.
We can do that. That's where I was wondering, cause
Yeah.
that way it's not.
No need to worry about it being out of perpendicularity.
time that someone
You do it that way.
went hunting.
Do it like that.
BMG.
All right, so here is just a
Animal.
turret that has internal and external tools, options on it. I'll show you ours in a minute. We'll go out and take a look at it. And then here is a regular holder in a live tool machine and a VDI holder. Our tool holders are BOTs. Then here is your gang set up in a dovetail. So this is the dovetail on there. So like if you had this set up and you ran a certain amount of parts, you might slide this whole system onto the dovetail, bolt it down, you're ready to run your next parts.
So, another question, so
Yeah.
like on the CNCs, so you know how we had that, on the manual lathes, we had the tailstock, and you hold up to it so you can stable it more, do you need to use those on CNC, or is there like a time, like if we had like a big old part in there?
Sure. Yeah.
How would you
Lots
do it,
of-
on the turret?
Well, on these, it has a tailstock on them. So we buy those TLs without tailstocks on them. But you could put a tailstock on it, you could buy a tailstock to go for it. We just knew that we were only doing chucking work and it wouldn't be an issue. The tailstocks on these are programmable, so they just go in and out whenever they got a foot pedal, or you can program them at the control, or you can program it in the program itself.
You have to home it,
Home what? The tailstock?
like if it's out, do you have to home it?
Know if you have to home it. Probably when you turn it on, it probably retracts. But I don't even know about that. You might be able to lock it in. I've never used the tailstock on it. I don't think we ever will use the tailstock on it. I just stuck a Jacobs taper and a Jacobs taper Morris taper adapter in it so it wouldn't get chips in it. They come standard that way because otherwise I don't know that I would ever want the tailstock. So tailstock supports the end of a long part. So like we would call it turning between centers or just chuck or turning center work. So you wouldn't have that drooping or chattering at the
So
end.
like whenever we were making our hammers, we wanted to work on as much material as we could at once, so we'd get leave I'd say 2 inches in and then have the tailstock holding it out. So we'd have like this part so we can run.
Yeah. Yep. So now if you have twin turrets, you can do what's called pinch turning. You can hold a part way out, bring both turrets in, and the even pressure allows you to turn across there. So there's some really cool, it's so funny because
Workarounds for everything, man.
people are super smart. Because oftentimes I think people look at what we do and go, there's some insane science and engineering that's going into these things. People are so smart.
Everybody was wanting to see this at my facility.
Yeah.
I took it home yesterday just to show it to them because it's wrong anyway, I need to fix it. And everybody's like, you made all that? I was like, yeah. And they're like, so how'd you do it? I'm like, come to class with me someday.
Magic box.
It was like, I can't sit here and explain to you exactly how I made this thing.
Yeah, I've had to take pictures and send it to my family and stuff of this is what I'm learning how to run. Like I'm learning how to set it up, not just like hit a button and let it go. I gotta learn how to. Like,
Yeah, because that's the stigma that you have to overcome is,
All you do is push a button.
yeah, all you're
No, I
doing
push
is
about 150 buttons.
right, yeah.
I need to learn how to read the code, and I need to know when to stop it, and all this and that and that.
I'm way beyond the point of trying to justify those things. People are like, you just push a button, I'm like, yep.
Yeah, but
Not
I make a
worth
lot of
it.
money doing
Not
it.
worth the explanation.
I make a lot of money doing it too.
So, then you have your basic, your Dorian, it's also on a dovetail, and just the drop-in tools, which is very similar to our manual stuff. These you've seen a lot of in the past couple days, just these collet adapters. There's just so many different ways to do things, and there's, I don't want to say that there's never a right way or never a wrong way. There are better ways and worse ways to do things. Just like we have the different styles of collets, TG collets, the DA collets, and the ER collets. It's the right collet for the right thing, and wherever you end up landing in a shop, you'll find places that they only do ER collets. ER collets are by far the most common. Older shops are going to have like TG 100 style collets, just because they're a longer taper, that they were around first. And then if you go to some place like this is like for this is a Harding collet, but it's very similar to what they call a RegoFix. A RegoFix, it has to have a machine that puts it together. So you put the tool holder there, then you drop the collet in, then you drop your tool in, and it's got a little machine that like pneumatically puts it together. So there's no cap on it. It's just pressed into it. Then they have hydraulic fittings or hydraulic adapters, and there's just so many different things. We can't cover everything, and no matter what we cover, if we just showed it to you for a second and said, hey, here's a RegoFix, we're going back to this, you would never remember it. So it would be invalid for us to even do. All right, you have turning directions, you have your right-hand tools, your left-hand tools, and your neutral tools. Pretty self-explanatory. Here's the designation problem that you have with this, though. This is called a right-hand tool. It's going left. This is your left-hand tool. It's going right.
It's just where the spindle's feeding and.
So what you do is you look at the tool. Okay, so when you look at the tool and the insert's facing you, a right one will be on the right, a left one will be on the left. A neutral one is still in the middle. But you always look at it as like the action of it facing you. So it's like whenever I go to the parts store and they're like, do you need the left headlight or the right headlight? I'm like, I need the driver's side headlight. Depending on which side of the, if I'm in the car or if I'm looking at the car, there's two different ways of looking. There's a left or a right, and I can interchange it. Stage left, stage right, those types of things. If I'm the audience or if I'm on the stage, totally different areas. So on this one, you're going to always look at the tool. It's going to be it's going to be left-handed or right-handed from that direction. Cutoff inserts, same way. Left-handed, right-handed, neutral. The idea is what they're doing. These are for our groove tools or our parting tools. We use a neutral because we like to groove with it too. So the idea is when you use this, it depending on which one you're using. If you're using a right-handed one, it leaves a little nipple on the area left in the chuck. If you do the other side, it leaves the nipple on the part that comes off of it. If you do it neutral, it's gonna be on the whatever side falls off, which is typically your good part. So it just depends on which way you want the little area to be left on it. If you only do a parting operation with that tool, then you get it with that kind of chiseled front. We want ours to do multiple things, so we use the flat front on it. Difference between parting and grooving. This is a part off tool with adjustable blade on it. This is a grooving tool. They both can do the same thing. Actually, the ones that I'm testing right now are basically these, but they're a little bit longer, and they will do all of the parting 1 inch and below. So they're really a groove tool. But so like this is 250, 280. I can get one of these for about 80. And so I'll probably buy these, and I'll probably keep some of these. So if you've got a part that's bigger than an inch and a half, then you use one of these. If you have a part that's an inch or smaller, then you use one of these. These will eventually be in your toolboxes, is my hope. This, and this, and this are all ways to get the stock
Moved out.
out. Okay, whether it's the first one was a gripper, let's say this is 2 inches, this gripper is just under 2 inches. You, by motor, drive this up, grab a hold of it, open your chuck, pull it out, clamp your chuck, pop it off. The other one comes in, it's coolant driven. You turn the coolant on, does the thing. The last one, this one, bar feeder, you open up the chuck, it's got a rod, and it pushes it into it. Now, on this one, when you're doing something like this, you need to bring the turret down, and as you're pushing it, you need to have the turret keep constant pressure on it. Because these,
How much, like, material could you have in a bar feeder?
this is probably a 6-footer.
It's like a rail gun.
It's not. I mean, it could be,
Yeah.
not on purpose, but it could be.
Throw it up to 30,000 RPMs, throw it, leave your chuck key in there, it'll figure it out.
So these come in probably 6, 8, 12, and 20. So you could have like, so what's great about that, if you run the same part all the time, let's just say you're making these, and you buy 1.25 inch stock, and if this is all you're making, you buy a 20-foot bar feeder, that way you never have to cut your stock. And you maximize the amount of parts that you get off of there. If you're running different parts all the time, but you got decent quantities that you're running, well, maybe a 6 or 6, 8, 10, 12, something. Maybe you cut the bars in half or something like that, you know. So, but the idea is you don't want to cut a bar in half just to cut up all the stock. So if you can leave the bar without cutting the stock, then it's just one less operation. You don't have to have a saw, you know. And if space is a premium, which it is, it always is, then that matters. All right. So different styles of work holding. You have the chuck, you have the collet, you have the spindle nose. This is really just the chuck has been removed off of here. It sits on the spindle nose. For everybody who's been on the manual side, you've already seen those kinds of things. Primarily, this is what we have on the CNC lathe. Is going to be some type of either keyed chuck or hydraulic chuck. And I'll show you the differences here out in a second. Process planning. This is one thing that I really want you guys to start doing. These guys are kind of doing this now. When you think about the way you do things, everything is a process. Start making lists of the steps. So when I first started in the shop, I would ask my lead, tell me my next 3 jobs that I'm working on. The best that you could. Our jobs changed all the time. Okay, this is what we're planning for your next 3 jobs. When I went home that night, I would list out all the tools and all the operations of all the things that I would do that morning. So when I came in on Tuesday, I was going to go grab my stock. I was going to go saw up all my stock for the day. Then I would go leave the saw, never have to come back to the saw again. I would chuck my part up. I would set all my parts in a row. I would face it off. I would turn the OD. I would spot drill it, tap it. I would have all my spot drill, and tap all laid out. Everything was a system, and nothing changed. And so that's how you make money. And again, just like yesterday, you want to be profitable so your shop can be profitable so that they can pay you more, so that they can do better, so they can have better equipment. Everybody wins on those types of things. So if you would start to kind of make some tool lists and just plans, I'm going to face it, center it, turn it, part it, think about the way that you think things should go. It'll help you kind of categorize those things in your mind. Yeah.
My question is, I get ready to set everything up to do a job, and it's like, what tool? It's a drill bit. Yeah, what drill bit?
Right.
I'm used to finding a list where you can, yeah, I know how to go down through the tools. If it says face off, I know what tool to use, but.
And on some of our programs, we have what's called a traveler or router. And it says you need a number 2 center, you need a 3/8 drill, you need a 7/16 tab, you need these kinds of things.
Why on most of the Haas videos does it have comments of exactly what tools we need and all that? Why don't we do that with our projects?
It's literally what I'm just saying. So,
Go around and ask people, and then you're aggravated.
Well, in the program that you have, there is like I think the program I ran yesterday, part 3, it had all my parts and what drills I needed in the program, like a 5/16 or a center.
and some of them do.
Yeah.
Some of them do.
7 and 8 had none of that. You had to go through.
So there's an evolution of these programs, and as we're constantly working through these parts and programs, if we were to go back and say, okay, so when we first started programming in our CAM systems, they did not do that. Now they'll let you bring that in, or you could manually do it if you wanted to. They also will create travelers or routers for the jobs, but again, even in those things, like in some of the things, like I haven't even said, on some of the things it'll say, use a VBMT 332. Well, it's pointless for me to explain to you, or to go say, hey, go get a VBMT 332. We haven't covered that yet. But if we go the flip side of saying, I'm going to teach you all of those things before we go out and machine, it's 5 weeks before we machine anything, and we'd lose everybody. So the idea is, what we've learned is we've got to get out to the machine within the first week, or else we lose people. So that means we have to send them out to things that we know work, and say, these are the things you're going to use. And we develop those things as we go. Because to say you need a 5/16 drill, well, if you don't know what 5/16 is, it doesn't really matter if I say you need a 5/16 drill.
Yeah, that was me, man. That
So-
was totally me.
Yeah, so by the time that you start to do this, so that works if everybody knows what a number 7 drill is. If everybody knows what a number 7 drill is, I can make a list of what everything is, and you'll be good to go. But if you don't, then it is pointless to have those things. If I handed you the traveler and said, okay, here you go, you got all the things that you need, you'd be like, then the next question is, where are these things at? And so, like, you end up having to almost kind of go backwards than to go forwards. And it's not a perfect system, and so, yeah, we've tried to build travelers and stuff like that. They become problematic in their own way. But yeah, I mean, those things are helpful. Like if I'm going to go to a job, and it's a job shop, the beginning of my program is going to have all the tools that I'm going to use in the order that I'm going to use them. But I know where those tools are, and I know what those tools are. So I can go to my program. It's probably even going to say the insert number, but I also know the inserts that we use. So I have to know all that background information before I even get to those things.
You're cool with us asking you.
Yeah, you should, because it really gives us the time to go, okay, so here's the profile insert. This is what the profile insert does. This is upside down. This is right side up. This one's no good. This one needs to be changed. So it brings us into some opportunities to have other conversations. So like on these guys, when they were doing their manual stuff, they had been drilling some holes. And so I said, okay, now I'm going to flatten all the drills out, and we're going to learn how to sharpen the drills.
Oh my God.
They were super excited about that, as you can tell. So,
That drill is still sitting in my toolbox.
yeah. So,
It's not sharpened.
yeah.
It's not sharpened, no.
I was doing the opposite way the whole time. They're just
That's what I was doing, I guess. But
And so then it's our opportunity to learn tool geometry as we're going through the thing. And then it becomes to the point where I can come to Chance and go, hey, this drill needs to be sharpened. He can go over to the grinder and then sharpen it out. But, yeah, like there are a lot of circles that overlap, as you kind of go through the thing. And I don't know that there's a way to do it perfectly lineally, unless you said we're always going to make these things. Or if we said, before you start class, you need to do this like 2 weeks of prep work. And no one would do it. You would, yeah. A handful, 10% of people would. Because some people, we used to do a quiz that was like, before you come to class. And like it was about the syllabus, and it helped us immensely because we didn't have to cover nearly as much stuff. And so what would happen, though, was only about maybe 30% of the people would do it, maybe. And then you ended up having to stop and teach the whole class the thing anyways. And so the 30% people were like, so did I do this for no reason? I'm like, yes, you did it for no reason, I'm sorry. You know? And so the other people were like, yeah, that's why I didn't do it. I'm like, you're not smarter, dude. You suck, you know? And then they were like, well, but we're still doing it. I'm like, okay, you win, you know? But so yeah, and those are hard ones to figure out too. So, but if you were working in a shop, let's just say, so John Yeager, who works at Garner Denver, when he gets his next job, it'll have a traveler or a router that says you're going to make 200 parts. You're going to use this material or this casting. It's going to be on this machine. You're going to use these tools in this order. Each part should take this long.
So that's not on your print.
It's a separate piece of paper.
Okay.
Yep. It's a separate piece of paper. We call it a traveler because it travels with the parts the entire time. And so like we had a packet at our shop that just went in a clear envelope and it went with the parts the entire time. It said everything about it from the time that we got it. This is what we would saw it to. These are the information that came with the material. So it said what kind of material it was, what it would be sawed to. It's told what every operation took, and every operation that you used, you keyed in a number on the computer when you started your time on it. And then at the end of the job, then I would go back and I would check everybody's time. If you ran over on time, then I came back and be like, hey, what happened here? I got pulled off the job twice for a hot job. Okay, that's all I need to know is why that happened, or material got ordered wrong and it was bigger and it took longer. And I would ask the question, if I quoted 5 hours on the job and it took you 3 hours, I would come to you and ask the question, why don't I take 3 hours? Well, we got a new drill and it drilled more faster. Yeah, found some way to work around. That's great. I just want to know why those things are happening. Because what I don't want to do is if that was a fluke, I don't want to adjust the time on the job because next time, then I think it should take you 3 hours. It goes back to 5 hours. So it just helps us keep track of those things. But yeah, so our shipping guy, when he shipped it, it even told him, you ship it on this freight carrier to this place. And so it just traveled with the parts.
Yeah, and if you're talking about like those prints, wait until, if Justin really wanted to, he can make them prints. Super,
Well, they do get
it'll
more-
tell you absolutely
And they
everything.
do get more complicated, but it's a
Super
progression.
complicated.
Yeah, it's a progression. And as you know things, like we will never say to a certain point, so let's just say on Eden's part, like I'm just gonna say, this is a half-inch tapped hole. I'm not gonna say what spot drill, I'm not gonna say what drill, because by giving him that designation of a half-inch tapped hole, he should know everything else from that. And so like that little chart that you had, the little stair chart, it tells you all that information that you need. But again, it's about the progression of learning where all those things are. I even tell people, I'll have people go to jobs and within the first month, they're like, I hate it here. I'm like, you don't even know that you hate it there yet. You don't even know where the bathroom is. No, you haven't had enough, yeah. But you haven't had enough time to know that you hate it yet. I mean, unless you really hate it, you know, like sometimes you know that you hate it, you know. In the same way, you might think you love it, and I'm like, oh, let's wait. You might hate it, you know. Like when I first started working at Starline Brass, started right before the fair, and they take off for Sedalia Day for the fair, and they give everybody a $100 bill. And I was like, best place in the world. 2 days after that, they moved me into wash and polish. It was 7,000 degrees in there. And from that day on, I hated that place. Hated every day. I mean, I thought of everything I could do to not work there. It was so hot that the day I got moved in there, I was in a pair of jeans and a t-shirt. So we started pretty early. We started at 6, and you go to break at like 9 o'clock. By 9 o'clock, my money in my wallet was wet with sweat.
No air conditioning at all?
And you're
Well,
used
it's
to
just that it's
Furnace
hot.
room.
Yeah,
Oh, okay.
it's hot.
Yeah, and so the
I
guys
was
told
over
me,
there, and then somebody told me about
so
it.
terrible. Now, other places in the building are totally fine. I'm not dogging them, I'm dogging that area. And so they told me, the guys, they said, hey, at lunch, go home and go get the shortest pair of shorts you got. Like Daisy Dukes. It was not comfortable, even thinking about it. And the most sleeveless shirt that you have. These guys were practically in 2-piece bikinis in there working.
Like cut-offs all the way
Cut offs
down.
all the way down. And there was acid in there too, and the acid was in the air, and it would disintegrate your clothes, man. It was terrible. I hated that job. And so I actually just, one night I couldn't take it anymore. I worked third shift, and I just left one night. I just clocked out and went home. And the next morning, the owner called me, and he goes, "What are you doing?" I said, "Nothing. What are you doing?" And he's like, "I need you to come talk to me." I was like, "I don't want to." I mean, I was like 19. And he's like, "Nope." He goes, "I'm not giving you your check unless you come talk to me." And I was like, oh my gosh. So he was super cool. He was pretty young. He was not the owner, but he was the manager of it. And he's like, "So what happened?" And I was like, "I hate it here." I was like, "I do." And he's like, "You've been here like 4 months." I was like, "Yeah, and I hate every day of it." And so he's like, "Well, what if I give you another job?" I was like, "Honestly, I've got such a bad taste in my mouth about the place. I don't think it's going to work." And he's like, "All right, so here's my check." And we parted ways. But that was the worst way to leave a job. You know, when you leave a job, you need to leave a job, you know, do it with some honor and respect, you know. You need to finish out your shift. I caused everybody else to not have the parts that they needed for the rest of the day, you know. And that was bad on my side. And so I've learned, hey, if you're going to leave the job, it's okay to leave the job. Leave the job well. You know, give your 2 weeks if they want their 2 weeks or whatever. You need to talk to them, have that communication about, hey, I don't think this is the job for me. I need to go somewhere else, you know, or because what you don't know is I've had a lot of people who started jobs and they did like the worst thing in the world and they were ready to quit. I'm like, go talk to the owner or manager and see what the plan is. And like, it might have been that they just had a fluke where they needed you to do that job at that time. And then next week you were going to go do the job that you wanted to do. You know, everybody at a job does something that they don't want to do for a while. So it's important to have that communication as best as you can. Exactly. Yeah. Everybody, I mean, guys at our shop hated to clean, but you still did it.
Yeah.
You know, and you're just like, I hate doing this, man. We were always like, can't we hire somebody to clean? And they were like, we did. And I'm like, it's us. Yeah, I got you. So, all right. I'm going to let you guys answer the questions on these yourselves. Unless you want, if you want to go through them together, we will. But before we do that, no matter what, just to wake you up, we're going to go out to the lathe. Yeah, you guys, you guys are really like I can't see you. Yeah,
Everybody else probably hasn't.
yeah. You and Hunter have just been like bobblehead, man.
I said I want to go to the shop because it wakes me up.
So we're going to go out. And
Sleep at night.
you're supposed to sleep at night. Yeah, if you're sleeping more than 6 hours a day, you're wasting time.
I couldn't sleep the other night.
So we're going to go out, we're going to look at this live tool machine, and then we'll come back in here, and then if we want to go through the lessons, or through the answers, we can. I'm going to stop the video, though.
Live tool machine. You gonna run a part for us?